Okay, so welcome aboard. We're on the home stretch to Christmas, so it's in sight and you're not too far away from a break. I know some of you are just doing some reporting this month coming up in December. I know there's been some changes in some schedules for some boards, so hopefully you'll be able to have that and put it behind you and then move forward for a nice break. So let's begin with our acknowledgement, and then we'll have a look at the focus for our next couple of months that we're going to be looking at. We respectfully acknowledge that we are situated on Treaty 6 territory, traditional lands of First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and others whose history, languages, and cultures continue to influence our vibrant community. And you may not be on Treaty 6. I'm coming to you from Camrose, which is on Treaty 6. And we acknowledge that we have many First Nations whose footsteps have started our lands and whose cultures continue to influence our communities. So today we're going to revisit a little bit on unit fractions because we said we would kind of hold off on that conversation until around the end of November, December, even though it was kind of in our November goal, just because we wanted to make sure that everybody was strong in money, because we're going to use the money again to lead into unit fractions so that students have an understanding about why we're doing the counting that we're doing. We're going to look a little bit more on the numbers, the two number outcomes that we're working on right now, especially as we start to move towards those bigger numbers. So this was kind of our transition time where we're moving from 50 to 100. Some of you were already beyond 100, but some of you were just saying, no, I'm not even strong at 50 yet. So again, just having a bit more time. And remember that there's no hard and fast that you have to be somewhere. We just gave some suggestions about how you might bridge each of the months together and where you might be. And so it's just that, it's a suggestion. I'm giving you some ideas of how we might unpack some of these pieces that we're going to look at. So I want to revisit where we're at. We're finishing November, so kind of where are we sort of transitioning to for December, January? And there's nothing different in February other than we start 2.1. Okay, we start regrouping. So we said hold off on regrouping until maybe we come back after Christmas, we get some foundational pieces revisited, all of those, and then we can start working on regrouping. And again, if you haven't done a lot of money, it gets me an opportunity to do that because again, I want students to have a context about why do I regroup to begin with? Like, what is the purpose behind it? It isn't about memorizing just a base 10 algorithm that, you tell me that 10 little squares are going to give me a rod and 10 rods are going to give me a flat. I can learn that, and our students are very good at learning that. But do they have a context for understanding why they're learning that? So if we back up a little bit and we did our money first, and we did our transitions there, then we can have that link to regrouping come right from the money. Okay, so we're looking at, this is the piece we're going to unpack today. We said we just hang on to that for a little bit, and we're just going to do it with the money. We're not launching into crazy numbers right off the bat. We're not naming numerators and denominators right off the bat. We're going to just try and start small to see if we can catch some of the kids who we might have lost along the way in fractions. We're moving towards 50 to 100. Again, some of you are in different places in here, and that's fine, because remember the yellow is a suggestion only, just trying to bridge us as we start working our way to 1,000. Okay, and so we see the same thing, that we're still working on analyzing quantities. We're looking at estimation. They should have a good, reasonable estimate of what their answer is going to be, or their number is, or what is it closer to, without using rounding, just approximately, where do you think I am? Those types of things. The natural numbers, are they odd and even? So we could do that by dividing money again. You get the same amount, I get a different amount. I've got this odd number that sits in there, or maybe it's a remainder, and it gets added to one set. So it could be an odd set, even set. And then we look at the contents of each set, whether those are odd and even. Okay, and then let's move on to looking specific. And I just want to remind you again that what you're seeing, remember in our year to glance, those bullets are your understandings. And so I have all my rows of cusps. As I go through and work through the knowledge, skills, and processes combined together to meet the understanding. It's the combined understanding stacked together that I say they've successfully done each of those understandings or met that understanding to say that, yes, they've met their outcome. And, you know, we say that they've successfully mastered it, or whatever your scale is that you're going to be using. So in order to unpack any one of these again, we still have to go to our curriculum document. And we're looking at, in this case, we want to make sure that we are seeing not only the understanding, this is the part that's in the year at a glance, but now I see what was the knowledge piece again and the skills and procedures that was attached to that understanding. And what are the key skills that I'm having to work through with the students in each one of those. Now, because we are moving forward with 2N 2.1, like it's ongoing, it's not one time, and we don't just do it 1 month. It continues to build as I progress through to my number of 100. I'm going to continue to reassess students over and over. So if I'm working at 50, I'm going to assess you at where you're at for 50. If you're ready to move to 60 or whatever number you're at, 70, I'm going to assess you at those. So I'm continuously revisiting, which you do in primary all the time anyway, checking for mastery as we move them forward. So the order in which the order in which more than 2 numbers are added does not affect the sum. And we had looked at that a little bit more in detail last time when we brought up the Cuisenaire rods. We'll look at it a little bit more again today. We have operational skills of visualize and compose. So can they see various different compositions when we show them? Can they itemize them? Can they write them down? Can they talk to us about it? Can they articulate it? Can they describe it? Or can they actually compose sums in multiple ways? So if I said, can you show me 17 3 different ways that I could take money? That would be my logical starting point because I have to learn the money anyway. Might as well use it as a manipulative at the same time. And so can I show you 17 cents 3 different ways? And it could be as simple as they counted out 17 pennies to start with, right? And work from there. But what are the multiple ways that I can show you 17? And I'm using probably more than 2 coins, obviously, that I'm going to get to that value. So what I see are these 2 skills in here, visualize and compose. And remember, we were just kind of holding off on the regrouping for a little bit. So we could do tons of addition, tons of questions for adding things together, but not for a deliberate regrouping in there. So we'll pick our questions carefully. I want these to be really strong because I'm going to need them for the third number outcome that we're talking about, the 3.1. So let's look at 3.1 again. So a whole number can be whole sets of objects, a whole object that can be partitioned into a number of equal parts. So that could be a part whole, could be more than 2 equal parts, not just 2 part, could be more than that, but that they could be equal parts. And as we're talking about equal parts, that's kind of a precursor as we start sliding them into grade 3 when they're going to be doing their math facts, where we're talking about the addition of equal sized groupings, which eventually takes us to our math facts for multiplication. The whole can be any size and designated by context, right? And this is really important. I didn't say the word fraction right off the bat. It just said I can have a whole that's in a context. The context could be a watermelon. The context could be their sandwich that they brought to school for lunch. The context could be a birthday cake that somebody brought to the classroom today because they were celebrating a birthday. So it's just, can they visualize wholes of all different sizes, all different shapes? And more so, you're going to find later as we talk about fractions, less on the circle side to start with, because the circles are a little bit more problematic than people are maybe understanding or realizing. Good intentions, things that kids can link to, cookies and pizzas, we know that, but not a great shape for a student to make some really intentional divisions on. I can fold a piece of paper that's in a circle in half, but it's really hard for me to come up with good thirds. I'm going to have to do my best guess because I'm not really going to be using a protractor. So again, it's using a shape that's conducive for a child to be able to manipulate at their desk quickly and easily. We're going to talk a lot about unit fractions today because that is the foundation of fractions. And although we're not going to throw the word fraction out right off the bat, it is the unit fraction that we will work with. And we'll start with money. Why? Because it's a context. Remember, it said in a context. So if I want to show you what a unit fraction is, I need to have a context that's real. One little square out of a rod in a base 10 is not real. It is definitely a perfect unit, but it's not a real world context that I can physically and tangibly understand as a grade 2 student. Money that's in my piggy bank, money that somebody gave me, maybe mom and dad started me a bank account, or maybe I've never seen money before, but either way, money is a context that I will continue to grow and see as I get older, and I will start to see it in a different light and use it in different ways. So again, let's have a look at, it talks about one whole can be interpreted as a number of unit fractions. That's what we're going to build today. And then we want to talk about that part to whole relationship, which we jump to as North Americans very, very quickly. But we'll start with that. We're not going to talk necessarily about the part to whole and name it like that, but we will talk about parts of a whole in terms of money. We see the skills of modeling, comparing, modeling. So modeling means I have to have some tools in my back pocket to show you. I can model my thinking. I could talk my way through the model as I'm putting it together, and I should be able to model it in more than one way. So again, I need to have seen more than one way. And that is important when you see the word compare, because compare is one of the highest order thinking skills that we can ask a student to do. That's a Venn diagram, for example. To compare something means I need to know more than one thing, because you're probably going to want me to talk about similarities and differences, and I can't compare if I only know one way to do something. What am I comparing it to? Is there a more efficient way? Is this a bigger value or a smaller value? If I've not seen that modeled myself, I have no means to make a comparison. So this is really important that we give them the tools to model, but we also give them the tools to compare. So you'll see that I've been keeping track sort of a list of the things that I'm seeing that are coming up in each of our sections for the outcomes that we're focusing on. Because we need to make sure that, remember, the students know these. So somewhere along the line, we always have to be intentionally teaching those to the students so that when I say to them, can you make me a model of 25 or 15 or whatever? So I understand as a grade 2 student what your expectation is when I create a model. That means I have to teach you what model means. I would have to show you model, what model is, and maybe model it outside of the math curriculum. So teach it to me with something that we've been doing. Maybe it's with activities that are in my desk or items that are in my desk, or I want to model tools that I can take out of, let's say, a pattern block. They could be the same color and then same shapes, and then there'll be those that are the same color and same shape, right? There's the comparison piece or the Venn diagram that I was talking about. But I need to see those. I need those in action. I need to do them outside of what it is you want me to learn in this learner outcome. Like, don't try and bog me down in learning the word or the skill that you want me to learn and tag in the math that you want me to learn all at the same time. If I can separate one from the other, then when I come in and I teach you the math and you already know what it means to model, because we've been doing a bunch of examples like that, then I can just really focus on the math piece you want me to learn and connect that skill of modeling to what it is you want me to do. Okay. So up at the top right here, because you have a whole bunch that we've looked at already, there are some that kept coming up over and over and over again that kind of work together. And so for the ones that we're going to be focusing on for December, January, and then early into February, we'll meet again, but let's just say including February, maybe we could look at compare, compose, visualize, and model. You're not going to have time to unpack 15 different skills in that time frame. So let's narrow it down to some 4 big rocks that would be very helpful and reflective of the things I'm going to be doing either in the skills and procedure side, in the knowledge side, or both put together. So you'll see that I just grabbed a couple of the words that you're going to be seeing in some of the statements that we read, and I've highlighted what they are. So compare, there's compose, visualize, model. Okay, so there's some words, but I'm going to go one step further. When you get the slide deck, you'll be able to go in and just click on all of these links. So I'm going to go into skills. And you'll see the same thing. I've just given you a couple of them here. I'm separating the skill out from the actual sentence of what that skill is supposed to demonstrate. And the reason I'm doing that is because I really want us to remember that I need to teach the word somewhere along the line. I can't just assume that they know what it means. And they're going to do that in kindergarten. They're going to do that in grade 1. They're going to do that in grade 2. You're going to do that in grade 3. You're going to do it. So yes, I'm going to see compare. I see it in grade 1. I see it in kindergarten. And how I unpack compare, I still am going to get to the essential understanding of what a compare is at that grade level. But every year we're going to revisit it. I'm not sure that I'm going to have to teach it as much every year because let's say as a grade 2 teacher in a perfect world, had they come through 2 years already of having done that, it's not totally unfamiliar to them. They've seen it before. They've heard it before, but now you're going to bring it up in terms of a slightly higher level thinking of a grade 2 content as opposed to kindergarten or grade 1 content. Last session that we met together, I had you go through and find the concepts in each of our statements. In this case, I've already highlighted them for you in blue. And do I see kind of the pattern we talked about before where I see the same concept coming up over and over? And yes, I do. So whether I'm visualizing, modeling, or comparing, I'm still working with the same concept from multiple perspectives is really what it's coming down to. You'll see that the unit is sort of put into a purple color, and that is because the unit fraction is foundational to fractions. And we do talk about unit fractions in our older curriculum that we just finished, but maybe we don't spend as much time on it as we could or should to really make unpacking fractions easier for students as they move forward through the grades. So we'll look at that today. At the bottom of your template, you'll also see skills. So we're working on giving you sort of a common little bit of a dictionary of what some of those words are, whether you choose to reword them a bit when you're doing with the students. These are not meant to be put on the board and for them to copy down. It's just really when we're unpacking it. So maybe we're all at least approaching it from some common language, some common perspective. We will continue to build on this. We're going to continue to refine them. And then hopefully after Christmas, we will have a complete document for you. Okay, let's go back to our slide deck. So yes, counting is still very repetitive. I'm still having to learn to count. And now that I'm going to do unit fractions, I'm going to learn to count by unit fractions. And I'm going to bring up why that's kind of important. So we want to make sure too that we're always in a point now where the students are very much in routine with us. They know what to expect. They know when we're talking about number, what activities we're going to do. So now's a good time to maybe infuse some new approaches or maybe a new engagement activity that still gets to exactly the same thing that I want to teach them. Maybe not out of a workbook this time. Maybe it's in form of a guided game. Or maybe it's in the form of an activity that I'm doing with a partner and I have to work my way through problem solving it. So just another way to keep the same routines that you have going, but just infusing some new ideas, some targeted outcomes that you want to hit, and multiple outcomes at the same time. It doesn't have to just be one item that you're talking about. So for example, let's unpack a little bit more 2.1. That talks about visualizing 100. Now remember, it'll be wherever you are in this stretch. As we're moving towards February, we're kind of moving towards the 100 to 500. Some of you are already at 100, some were at 200. But remember that we want mastery of 100. We want them to solely and truly understand all the ins and outs of 100. Because if I can navigate 100, then getting to 200, 300, 400, 500 really isn't that big a deal. If I can't navigate and understand place value within 100, I'm not likely to be any more successful when you move me into 2, 3, 4 or beyond. So that 100, understanding the 100 and everything that encounters within the hundreds is really, really the foundation that we need to build on. And if we need to spend a little more time doing that, then we do that. This is also where we're using skip counting. So we're going to be skip counting, making tens. You're skip counting by tens, by twos, by fives, by 20s, by 25s, right? These are the ones that they did in grade 1, but since they didn't all arrive perfectly ready with those at your door, you're still probably working on these as well. Money again, there's my dimes, there's my nickels, there's my $5 bills, there's my toonies, there's my $20 bill, there's my quarters, right? This is the money. And this, if I have to learn the money anyway, then why wouldn't you just put those in front of me? If I'm going to skip count by 50s, I can take a $50 bill. I can take 50-cent pieces from the money app that we have, right? So how do I model using money for skip counting? How do I model that associative property where I can add numbers in any order? When I put coins down on the table, if I have a nickel, a dime, and a quarter, and I change it to a quarter, a nickel, a dime, will that change the order, or the order change, but will that change the value of my total amount of cents on the table? And the answer is no, but we don't want to say no. We want them to tell us that. We want them to add them up. We want them to tell us, does this change the total? Starting with 2 coins, then add a third one in, right? And just keep changing it around. What if I use 2 nickels and a dime, or 2 nickels instead of a dime and on one side and a dime in the other? Will it change? No, I have a different combination, but I can still end up with the same total. So this is the power of money as a tool, but also as a concept. I need to understand the money, be so versatile in it that you can just keep throwing it in front of me and I can keep going back and forth. Use it as a counter, use it as a tool, use it as a concept, whichever I have to do. So again, let's start with a little bit of money. I'm going to throw this into the chat box just in case you don't have your link on your computer. If you do, then by all means, just bring it up, but I'll throw this in the chat box. And if you can bring it up, I'll flip between my screen and the PowerPoint. And so again, this is a great way for me to work with the students. I can drag out money. I can say, can you bring me out 2 toonies? I can say, can you bring me out 5 toonies? Like whatever, so they can count it out. But now I also know that they know the toonies from the loonies, from the quarter, from the whatever. So that hopefully is already well under control, and we know what the values of each one of these are. Remember, at the bottom of our tool, I can change what I bring up. So I could change it to, let's say I bring up 10 of something. So I could bring up 10 toonies, which now gives me the opportunity to say, how many do I have? And they might say 10. They may count them one at a time. You might say, how else could you show me that you have 10? Well, some kids will say, I see 5 and 5, right? 2 5s is 10, good. Some will say, I see a 10 frame. Great, you see 10. Some will go 2, 4, 6, 8, 10. So every opportunity I have when money is like this, you leverage it for everything you can. Every outcome. It's not about doing one outcome or one of the knowledge, skills, and procedures. It's about blending them together and using those teachable moments every time you have them. I could skip count by 5, 5, 10. Okay, that's all I can do, but it's skip counting by 5s. What's the number of coins I see? 10. What's the value of the coins? That's a good question to ask so that they know the difference between the number of coins and the value of the coins. So now I'm going to count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So having that conversation not only just gave me a skip count practice, it also lets me discern whether or not they know the difference between the number of coins sitting in front of them and how much money do you have? What's the value of the coin? Okay, so here's my task to you. I'm just going to get rid of mine here. I would like you to drag out 103 cents, any way you'd like. And maybe if you can, just bring it up sort of in the top left-hand corner. However you want to show it to me, doesn't matter. So drag out 103 cents, 103 cents. And so if they had little bags of money on the table, whatever they dumped on the table, we would ask them to show us 103 cents. And so you could start walking around and they could even just stick their hands up, thumbs up when they think they've got it, quickly look at it, that they got 103 cents. And if the answer is yes, then we say, don't touch it. We want you to leave it on your desk. And now I want you to find me another 103 cents. So let them count it out again. Let's get to 103 cents. And if I'm not able to count to 100 yet, then just make it smaller. Make it 53 cents, 43 cents. You could differentiate as you walk down the rows and give me an appropriate number for my counting ability if I'm not able to go to where everybody else is. So whatever number, we'll work with 103 cents for now. So once you've got a second one, put your thumb up, and it has to look different than the first one. I'm going to come around, have a look at it. And if they've got it correct, I'm going to say, don't touch that one either. Now we want you to show us again 103 cents. So the whole point is that yes, I can count the coins. I know the value of the coins. And I also now recognize that 103 cents can show up a whole bunch of different ways. And that's good. That's one of our outcomes. But I've nailed a whole bunch of things in the process of doing that. Sometimes they came to us when we did this with the students and they said, well, we don't have enough money to show you another 103 cents. So then our question was, how much money do you need? Okay, that's a deeper question. So if they know they had 90 cents, then they might go 90, 100. So I need a dime, and then 1, 2, 3, 3. So I need 13 cents. Great. Why don't you come to the back where we have a cash register drawer of fake money, and you tell me how you would like your money. So they might say I'd like a dime and 3 pennies. They might say I'd like 13 pennies. If it works out to 13 cents, however they request it is what I would give them. At some point though, when we do exercises like this, we're going to ask them, and this is probably leaning even more towards a grade 3 concept, but we want them to be efficient. Can you use the least number of coins at some point? And they're not learning that quite yet, but that's a word that you kind of want to tuck in your back pocket. If you have some high flyers, and I'm sure you do, that you have some who can count money, they know it inside out, they know dollars and cents, then they would be the ones that I'd say, okay, can you show me one of your 3 most efficiently? In other words, the least number of possible coins I could have with 103 cents. So a loonie and 3 cents. Okay, so then this is the kind of thing that we can do here. I also screenshot any of these when I make slide decks. This is where I take them from. Okay, let me just go back to my slide deck for a second. So if I were to say, I dragged out, okay, and if you just watch my screen just for a second, I dragged out some coins. So we should be able to do some subitizing in grade 2 already fairly efficiently. I can see 3, I can see 2 is 5, plus another 2 is 7. Like that's the kind of thing by now we should be able to start putting on to our conversations with them. So how many do I see here? I see 7. And how many do I see here? I see 5. A group of 4 plus 1 is 5, or I see 3 and 2. However, you can ask them how they see it. So if I ask them, how much money do I have? We would hope that from their grade 1 math box that they're seeing 7 plus 5 is 12. They may go back and recount them once individually, the one-to-one count, which is not where we want to go, but that's okay if that's where they start. But eventually I want to have a conversation about, okay, so I see that I have 12 loonies. So I wonder if instead of walking around with 12 loonies in my pocket, could I make a trade for something? And some kids may say, well, you could trade 2 of these for a toonie, and you could trade those for a toonie. Absolutely. That's a great way to go. Some kids may say, well, you have like, these are like $5, so I could replace it with a $5 bill. So I would have these 5 would be this, and I still have these 2 left over. Okay, like that too. This one I could replace with another $5 bill. And now that I have 2 5s, some students will say, but you could just make it even smaller and just make those 2, 5 and 5 is 10. So I could make them a $10 bill. Great. So we're already into efficiency. And I still had 2 loonies left over. So there's my $12. This Converting from loonies to a bill is a real world context of conversion. Why did you tell me that 10 little units equals a rod? Because 10 little units stacked side by side do equal a rod in the base 10 system, and that's perfectly correct. But if I started doing a whole bunch of questions like this first, when I move to the base 10, I already understand what converting is. I've seen it in action. I've seen that I don't have to walk around with 12 loonies in my pocket in order for me to have money in my pocket. I could. There's nothing wrong with it. I could, but I probably don't want to. I don't want to have all that coin in my pocket. So this is where I can start to model for them what converting is all about, the reason we do it. Okay, and we don't always have money in math class that we can convert. So sometimes we use base 10 blocks. Doing money all the way till Christmas as the only manipulative is not unrealistic, because you can almost take 65 to 70% of your outcomes in grade 2 math and cover them using money as a manipulative, just like we're showing. So if I keep using it over and over, I'm learning it, got it, because then we can have our financial literacy conversations and do all those kinds of things and do a little bit of buying and spending, and you can give me a mock store. But now I also have a context that when you bring out the base 10 blocks, oh, okay, yeah, this is what we did. We used to take 5 of these and make a bill, but in the base 10 blocks, we use 10 to make a rod. Okay, they have that understanding. So the other piece about money and place value and counting, because at some point we want to be able to see whether my estimates, my additions are even reasonable. I also want to be able to say, do you know what place value is, right? And I don't want to throw that out to them right off the bat, but I do want to introduce them to what place value is. And typically what we do is we bring out columns. And right now, if you ask older students, not if you haven't done them with them in class yet, if you ask somebody what's place value, most people will say to you, oh, I know what that is. That's the columns when you do 110s and hundreds. Well, that's not completely wrong, because it is. It's how we identify place value, but it's not place value. That's just a tool. It's just a sheet. It's just a foam mat or whatever you have. But that's what people have identified as place value. I recently did a parent night too, where we were talking about some of those things, and we talked about place value and money. And somebody right away, one of the adults said, I know what that is. That's where they do those columns. The kids bring home those columns. They do 1s, 10s, and hundreds. And I said, that's right. That's how we determine the value of certain numbers and what place they hold. But I said the place value of a number can go beyond just what's in those columns. So what if we didn't bring out the columns right off the bat? Again, I'm not saying don't do them. I'm just saying, what if we just said, instead of drawing a line down here, we just said, here's some 10s and here's some 1s. And that I can see in money. I can see the 1s. These could be 1s. There's 2 $1 bills in each, or 2 $1 coins in each one of those. The 10s, well, that's an easy one. I have a $10 bill. I can see it. I can see these are 10s. So I could ask, what is this number at the top? So 10, 20, 30, 40, 2, 4, 6. So 46, right? So I could write 46 down, or I could put it on the side if that's what I wanted. And over here, what's my number? Well, I have 10, 20, 1, 2. So 22 is my number. So 46 plus 22. There's no regrouping here. And that was our whole point of doing some modeling and some questions and practices. So again, if I was going to add these together, I would be taking all of my 10s and putting them together, and all of my coins and putting them together, just like they built 103 cents, right? Same idea. So then I would have 10, 20, 30, 40, 50, 60, and then 2, 4, 6, 8. So then I could say I have 6 $10 bills and these coins. My question might be, are there anything here that we could convert? So I don't have to walk around with quite as much in my pocket. And if they say no, that's fine. Just start there. That's okay. And if they should be able to realize that a $50 bill, if I've done some work with them on the basis of 10s, then I know that 5 of my 10s could be traded and converted into a $50 bill. So I'm converting. So 5 of these are gone. I've still got 1 left over. So I could walk around with these coins in my pocket. That wouldn't be so insurmountable. I mean, it's not just 1 extra coin. But some students quickly said, but you could make this one look like these. You could make this a toonie. I said, okay, we'll convert our 2 loonies into a toonie. So I end up with a $50 bill, a $10 bill, and 4 toonies. And we can double check 2, 4, 6, 8, right? So I skip counted by 10s and skip counting by 2s as a quick check. Model, model, model. So then my question would be, just like we did 103 cents, is there another way that you could create $68? Could you have different number at the top and a different number at the bottom? And when I added them together, I would get $68. That is a really good question for grade 2s to play around with. And again, I can see that different combinations of different dollar amounts can still end up with the same thing. Okay, how do we do this for cents? Same way. If you want to just do cents. So some people said, I've been only doing cents. I haven't included bills. And that's fine. Then just do cents. So my target is 100, but I'm only dealing with cents. So I might have 30 cents plus 55 cents. So show me 30 cents, show me 55 cents, however they want to count that out. And how much money do we have in total when we pull them together? Is there anything that you can trade so that you don't have quite as many dimes or nickels, depending on what they used, or pennies, that would just make less number of coins in my pocket? So I can definitely start with cents. I don't have to go to dollars right off the bat, but we should be able to go versatile between the two if we know the values of them. Okay, so always take advantage of skip counting and converting. That's the premise of base 10's system, and that's what we want them to be able to do. We can do this kind of idea as well when we talk about Cuisenaire rods, but I'm going to just leave this one. Well, maybe we won't. Maybe we'll go into it right now. We'll come back to money again anyway. So again, I'm going to grab this one. I'll put it in the chat box if you don't have it. Okay, and this one doesn't have the numbers on it. When I click on the colored dots on the side, I get my Cuisenaire rods. And I think most of you were with us in the last session, so you saw us work with these, but we'll do a really quick, super fast sort of overview. But there's my 10 different colored rods. Each color has a different value, of which I'm not going to tell the students that because they'll figure it out if they haven't already used them and know them. But in any case, we have these 10 different rods. The orange is the longest, the white is the shortest. And I could ask them something like, if I got an orange rod, you can just drag them over. If you need another one, just hit your button. So here's my orange rod. Which of these rods could you put on top here so that there's nothing hanging over and there's no holes? And I don't care what colors you use. Okay, it could be any color. So let's say I grabbed a yellow. Okay, put a yellow one on. So I'm going to try a green one. Oh, nope, that's too long. That's not going to work. I'll try a pink one. Yep, but too short. So it looks like this one might fit. Okay, well, there we are. So now I'm going to say, can you find another combination? Show me another combination. Okay, well, what if I want to use that one I didn't get before? So I'll try that one. Let me try this one. Oh, that's too short. I'm going to try. Oh, my pink one fits on there. So this time I got 2 of them. What am I showing? I'm showing the same thing, that addition of multiple different colors still covers the orange. And it doesn't matter what order I put them in. If I had done the pink first, for example, and that's a question to ask them, followed by the green, do I still have the orange? And the answer is yes. I haven't changed anything. The length is still the same. It's a perfect fit. The order I put them in still covers the orange. And I could ask them to show me multiple variations. Just pick another one, a long rod, and just say, show me different variations of that. So that's just the visual of the same thing we were doing with money. I can add in a variety of different ways. If the students have never done Cuisenaire rods or haven't actually done multiple additions of different numbers, this is actually a better place to start because I get a visual of just playing with a tool. I don't have to concentrate on the number. Right now, I'm just concentrating on the color. I could say, take the orange one and can you find me a layer that you can put on top there? But the layers have to be the same color, right? You're not allowed to use different colors like you did here. Well, again, they'll try. I could take a yellow one and I'll find that I can put 2 yellow ones on top. I could put a whole bunch of red ones on top because those will work. So I drag them over. So I used 2 yellows. I used 5 reds. I will find that when I use the white ones, I will just drag a couple of them over. But what I have is 10 of these will line up. So now I know that the orange is 10 units long. Whatever the unit is, they're 1 centimeter actually. They're 10 units long. That would make this yellow, since I only used 2 of them, what and what gives me 10? That's identical. 5 and 5 doubles. If I skip count by 2s, how many do I need to get to 10? 2, 4, 6, 8, 10, 5. So really what you've done here is you've built all the different multiples that I can for 10. It's like looking at the math fact for 10 in a visual. That's exactly what you did. 1 times 10, 2 times 5, 5 times 2, and it'll be 10 times 1. They don't do that in grade 2, but that's what you built. And this is the power of just playing with the rods and doing it that way. Then I can do additions. I can do any number. I can go to 20. I can go to 100. I can change whatever I want here, and I can just keep going. Just a couple of other notes to look at. At the top here, there's a section called Teacher Resource. When you click that on, there are already pre-made activities that you can use with your students. If you've never used them before, there's beginner ones. But if you have used them before and you're looking for something specific like a unit fraction, or you're looking for components of adding 2 numbers together or whatever, like the activities are already created, so you don't have to go in and make your own necessarily. Just getting the kids on here or putting the Cuisenaire rods in front of them is even better if they can just have it on their desk. That would be the important piece. It isn't important for them to know what the number is, not initially. All they need to know is I have long and short rods, and I can combine them in a variety of different ways. If you need them to figure out how long they are and they haven't connected that 10 whites across, it makes the orange one 10 units long. At the bottom of your screen, there's a section here where you can turn a grid on in the background. And now I see the grid on it and I can count them. I wouldn't do that though. I wouldn't do that for a long time. Let them just get this concept of different colors can be combined in different ways under wraps before we start worrying about just throwing a number in. And that's one of the things that happens way too fast in Cuisenaire rods is we just let them play for about 5 minutes. We let them make a couple of trains, put some different layers on, and we say, okay, did you know that this is 10? And now I want you to start adding an 8 and a 2 and 7 and a 3 and show me what those look like. Those come, but just let me get this behind me and make sure that I'm really good and grounded in it. The other thing that you can do is if you're not going to use the virtual one, which is I prefer the ones on the desk with the students, just print off a sheet of 1 centimeter grid paper and they'll fit perfectly on there because each white is 1 centimeter. So that's how they're designed to fit. And that gives you some options. Okay, I'm going to go back to my slide deck. So again, we've got the Cuisenaire rods. They see them lined up. They see what the lengths are. They know that the orange one is the longest. We'll skip that one because we already did it. I could do some very basic addition. Maybe I want you to work to 18. Maybe I want you to work to 24. Maybe I want you, so can you show me what would make 24 if that's where I'm at? Can you show me what would make 18? So all the different combinations that you need, they can start to write them down. If you've got a whiteboard that they can write it on, and they can just erase and rearrange and do whatever. Okay. What I want to get to is that understanding. That doesn't matter what order I put on top of the light green. Is it white and red and white? Does it matter? No, it doesn't, because they both still line up to make the green. Nothing changed in the length and the total sum of the distance that these two went, as neither did for 3 individuals. So it's the visual that I can add numbers in a variety of different ways and come up with the same total. Same thing here. The student was building a wall. And originally what I asked them to do was just to use 1 color. But the student said, well, do I have to use 1 color? Or can I make a multi-colored wall? And I said, well, I guess it wouldn't matter. As long as your wall doesn't have any holes and it doesn't hang out, because your wall isn't going to won't hold up the house if it has kind of holes in it, then I guess you're right. You can go wherever you want. And so that's exactly what he did. This is just a simple situation, and this was done by Michelle Dean. She did this at Makata one year, and it was brilliant, and the activities that she put together. But just you can print these off on from the internet, all different kinds of wheels. So if I was working on 16, 26, 36, 44, 49, like whatever number you want, I can just put the number in the center. And again, I can differentiate based on what you are able to do. So I've got some high flyers that are at 100. I've got some kids that are still working on to 50, right? Just whatever number they're at. Whatever I put here, I can show that as an addition. I could show it as a subtraction. However I want to, I need to be able to represent that number. Now, I would say even one step further, I wouldn't just do this wheel with Cuisenaire rods. I would include money. Can you show me that number in money in a variety of different ways? You can't show me the same money in every section. Could you show it to me with subitizing cards? Could you show it to me with just doing, even if you've done base 10 blocks with them already, then this is a good place for us to put it in, right? So a variety of different models, not just one tool that I get to represent those numbers. Number lines, the research says, and I just recently attended a session with Dr. Nikki Newton, and she is all about counting. She's brilliant. She's a researcher and mathematician from the US, and she does a lot of presentations for K-2 in particular, at all grades, but really K-2 is where she really just sort of shines. And what she's done is done a lot of research on how children learn how to count, but also the effects of number lines, and that we don't maybe use them as often and as frequently as we could. The more we can put them in front of our kids, the more likely they have a new model to show us and use to explain. So the number line helps them to internalize a concept, not just see it and hear it from us as we talk about it, but they actually do it. They put things on the number line. They physically can put it on and make a connection with those numbers that are on a number line. And the reason this is key is when we start talking about unit fractions, we teach so much counting in primary. We teach them to count to 1,000, in some cases 10,000, 100,000. But we basically, in kindergarten, grade 1, grade 2, we talk about, let's put numbers on a number line, 1, 2, 3, 4, 5. We can skip a couple of numbers. Can you fill it in? We spend routine amounts of time teaching them how those numbers are ordered. I can skip count. I can add numbers with the number line. But then why don't we put fractions on there and do the same thing? Like, that's an important piece that students need to see. So recently in a grade 1 class, we were working on number lines. We introduced number lines to grade 1s. But we felt it was important not only to show them what a number line was, and they all had one on their desk. It was taped to the top of their desk. But we wanted them to understand how a number line functions. And so we had them make their own number line. So we gave them just a blank line that was on a paper. And we said, let's look and talk about all the different pieces. We talked about what's a horizontal line and a vertical line, because I wanted them to see vertical hashtags on there are equally spaced apart. We talked about all those pieces. We said, okay, now you're going to make your own. And one of the most important pieces on a number line is that 0 is at the end, because 0 to number 1 is my first distance. It's the most important part of the number line. And often kids skip that part, right? They start at 1. They forget that when I'm measuring, I actually start from there, from 0, and then measure away. So it's really important that we understand and we point that out to them. But also, this is how I learned to count. And if you wanted me to skip count by 2s, I could go like this, I can go like this, I can show the hots. So we had them give the line, they start with 0, and we said, find an item that's on your desk. We had money on their desk. We always have money on their desk. Some of them took a coin, some of them took a toonie, and they used the toonie, marked it wherever it ended, they drew a line. And then they marked again and drew a line and marked it again. Some of them used a dime. Some of them used an eraser. Some of them used a piece of paper, like whatever. It didn't matter to us what they used. No number line would look the same, but they understood how to build a number line and how it worked. And I think that's really important for kids to know. So if I wanted to look at numbers from 1 to 20, for example, if I wanted to use my Cuisenaire rods, then run off a number line that has them at exactly 1 centimeter units apart, because then I can lay my Cuisenaire rods on top, and I can put a red one right in here, and you'll see that it's actually 2 units long. How do you know? I could ask student, how can you prove to me that an orange is 10? Well, they could lay it on here and they could see that it stops at 10, right? There's a proof. I can show it to you. I can model it for you. We can also use the DESI racks, right? And those are also really strong ways for kids to see numbers. These DESI racks, the ones I'm showing right, this is just part of it. But this gives me a way to show a teen number when kids don't get the teens. A teen, as shown in our curriculum, especially in grade 1, we're talking about 10 and a number is how we're explaining it to them. Well, here's my visual. Here's my 10, my orange rod, and a number. And my number happens to be 4. So 4 and a 10 gives me 14. How can I prove it? I can see I'm ending at 14. So DESI rods are nice because I can use the Cuisenaire rods and I can also see multiple different ways. Could you show me 14 another way? Yeah, they could have another track down here and come up with 3 different ones. And you could even say that you're only allowed to use 3 different rods or 3 colors or 3 rods, just not even different colors, 3 rods. Because if it was 15, they could even come up with 3 5s, and that would be a correct answer. So you have to use 3 rods to come up with 15 or X number of rods. It doesn't matter. But the DESI rods lets me trial and error and see what my totals are as I go along. These also have a backside track to them. So now if I wanted to model subtraction, so what if this was 40? I wouldn't necessarily line up for tens. I mean, when we get to bigger numbers, we just tell the student, we're going to pretend we're going to end it wherever we end it. You know, that's our end number, but you can assume that the rest of them are all filled in. So let's say that this was even at 40. And I would ask them, what do I see happening here? I see 40 take away 6. How do I know it's 6? Because I can count back 1, 2, 3, 4, 5, 6. I know green is 6. There's another argument. What do I get when I have, in this case, 20 take away 6? I get 14. I could just cut these in half, right? And I could just mark it off. So there's different ways for me to do the DESI tracks as I move forward. So I can use them for addition. Every addition question you give me can also be a subtraction question. So whichever way works better for them is how we're going to work. So here's my associative property where I can add numbers in all different orders. If my goal was 21, I have an orange and a white, 2 oranges and a white. If my goal is 21, what are ways that you can create 21? And these go up to 50 on one half, and then there's another half that goes to 100. So I have my 100 possible combinations. I can skip count. Here I said I've got oranges on the bottom. Can you show me the same number using skip counting by 5s? So they filled in the 5s. Skip counting by 10s, skip counting by 20s if that's what you want. I could use 2 oranges. I can use my $20 bills, right? All of those pieces. So one of the things that Dr. Newton said is when you're working with numbers that have a tens place in them, especially the teens, make that look a different color. And so that's where the Cuisenaire rods are great because they're orange. Everything else is a different color. So if your base 10 blocks have those multicolors, that's perfect. If they're all yellow or all orange, then if we can flip maybe between an orange set and a yellow set so that they see that the tens are a different group. She said one of the things that they'll see getting to 100 is it makes it easier for them to recognize that this is a tens group, not just all the same thing. So let's talk a little bit about those unit fractions. Unit fractions, this is an opportunity for us to kind of tool back a little bit and just maybe revisit them in a way that we haven't before. Nothing that we've done has been wrong. It's all been good. We just maybe don't hang enough time in there. And now that we see that fractions have been introduced at much lower level, this gives us an opportunity to kind of retool how we approach them and maybe what our thinking might be. So very quickly, I'm not going to read any of this stuff. In 2010, there was some research started on fractions by a doctor working in Ontario. She's continued. It started in 2010, and her work was centered around why do kids struggle with fractions so much? And more so, how can we help the teachers to make that learning experience easier for the kids and easier for the teachers to teach? So in 2010, she did some interviews first, and that was with teachers and students. And what she found was the teacher said fractions are tough to teach, and the kids said they're tough to learn. So that was the 2 resounding pieces that came out first out of the research. The second piece was that she determined that as she was going through the work, that typically students who don't get fractions or the concept of what a fraction is representing in earlier years don't tend to make that up as they get older or bigger or wiser. They just don't seem to connect to it at all. So it's one of those things that the foundational pieces are really important for us to build a good conceptual understanding so that I can tool them up later and use that for further learning and further applications. And misunderstandings that they range were common misunderstandings, and they had some common steps to getting to those misunderstandings. And that's the work that she's been doing since then. If she works with Ontario teachers, she goes and identifies the problem, or they say, here's what we keep seeing over and over and over with the kids. So then she goes back, she looks at how that happens, and then provides tools for the teachers to use to try to offset that, all of which we have access to, which is great. But there are sort of 8 big areas that fractions fall off the rails. And I just want to share those with you quickly. I'm not going to go through the 200 pages of research. The first of all is that students don't connect the word fraction or fractions, the number of fractions, as a number. They believe fractions are fractions. And I've had that conversation with a student before when I say, can you show me what 1/2 is? It's called a fraction, right? But what does that mean? What is a fraction? Like where is it a number? It's not a number, it's a fraction. So they just identified that notion, the visual, the 1 over something, 2 over something. They just call it a fraction, but they never connect it to being an actual number. And that makes a lot of sense. When I first heard that, it made total sense to me. They don't understand that there's a relationship between those numbers. So just because I said to you, I took a cookie and broke it in half, and I gave Nicole half and I got half, I got one of 2 pieces. That does not necessarily mean I have got it in my head that 1 out of 2 pieces is a relationship between 2 pieces of a whole. All I saw was I got a half of cookie and you got a half. They don't internalize that relationship. And that would be the kids who will often say 1/3 is bigger than 1/2. Why? Because they're still thinking in natural and whole numbers. They're still thinking that 1, 3 is bigger than 2, 3 is further on the number line. So 1/3 must be greater than 1/2. They're not in fraction mode or relationship mode. The second thing is that we tend to move to an algorithm too quickly. We assume that if we've done examples like cut an apple in half, cut a cookie in half, do all of those kinds of things, and that we just show them when we color in a circle and we have 1 piece colored in blue and how many other pieces weren't colored, and that will tell me how many pieces there were in total, that they must really get that. And so now we're ready to talk about, do you know that I can write it as 1 over something? And the something on the bottom is how many you covered. Like this is the part that we count it out in our circle. That's my total that I saw, so total pieces. That's a quick slip. And that's it is in reality, it is actually what we do. We in North America, we do jump to that fairly quickly. We just make the assumption that kids are with us and that they've got it. The inconsistency of language, and these are not in any order, right? It's not like one's more important than the other. That students said it didn't matter where they were and what school they went to. When they walked from one room to another from year to year, the teachers didn't say the same thing. One teacher would say 2 over 5. One would say 2 out of 5. One would say 2/5. And for the kids who were still struggling with the notion of what a fraction is, that was really confusing for them. So that's a good PLC conversation to have in your school. Like, what language do we use in our building, in our wing, in our whatever? Just have that. How do we say it? And what would kids hear in our hallway when we talk about a lesson like that? Would they hear something consistent, or did we all say it a little bit differently? So having that conversation would be a really important one. The lack of connections to real world, like where does 1 over 2? Okay, so you cut an apple in half. So what am I supposed to do with that? Money's a perfect opportunity. How do I connect a unit fraction or a fraction to money? Money I can carry in my hand. Money I can see how I can break it up. So there's that real world start again. So that's that money piece again, brings it right back to us. Bring it out, bring it out, bring it out as much as we can. So there's a unit fraction conversation. We don't give enough time to it. And because we don't give enough time to it, kids don't make the connection. But that's just like what you taught me when you put 1, 2, 3, 4, 5, 6, 7, etc. on a number line. This is working the same way. I counted by ones. I hopped one. Every one that I hopped, I got a new number. 1, 2, 3, 4, 5. Well, this is the same thing that we need to do with unit fractions, but we seldom do that. We kind of jump to it. You can color it, you can count it. We must be good to move on. The why behind what we do with fractions. Why do we find a common denominator? Why do we invert and multiply when we are dividing? Those are all absolutely correct procedures. There's nothing wrong with any one of those, but the lack of understanding of why they work is often not there. And one of the things in her research that Dr. Bruce found was that the teacher said, I don't know. My kids do really well in fractions when it comes to procedures. I can teach them. I know how to do it. I'm good with doing it, but I don't know that I know why it works. I just know it works. And so again, it was just that, what kinds of information do I need to support you so that you can answer that question if a student asks, or even ask them. How we represent fractions. I had mentioned this earlier, that in North America, the last two here that I'm going to cover are about North American teachers, so US and us. We jump to parts of a whole instantly, right? The broken cookie, the slice of a pizza. We go straight to parts of a whole. Now, is that wrong? No, because that is what a fraction is. We are going to get to that point anyway. But we also need to acknowledge that there are a whole bunch of different representations of what fractions are. So when you get the slide deck, I encourage you to click on this yellow representation. All of the things on that sheet we teach in our curriculum right now at some point, not all in grade 2. But fractions could be boys to girls. That's a ratio. It could be parts of a set. That's a fraction as well. Not just a cookie, a pizza, a square that we just cut in half. It could be multiple things in that set. And it's important that students hear that fractions, this is one way that we can do it as parts of a whole, but that's not the only way. The other thing is that North Americans, and open up any of your books, look at any of your worksheets, this is so true. We have a fetish with circles. We go to circles, cookies and pizzas in particular, way faster than any place else. These last two, especially this one here, in countries that outperform us, circle is the last thing that the student sees in a fraction. They start with squares, they start with rectangles, because those are things I can fold on my desk. Even if I'm not a perfect folder, I can still do it. They do hexagons because those have lots. They use stars because I can fold those in multiple ways. So just shapes that have a variety of different folds so I can see the different parts. It's not just in a circle, a half or a quarter, because those are the only ways that I can fold those quickly, especially in grade 2. That makes sense. A third, a fifth, when I have 7 pieces in a circle, I don't have a lot of 7s in my world, really. Even as an adult, I'd have to think hard about where I have a 7. But it's a real number, and for sure, I can have things divided into 7s. But it's not easy for me to draw that. I can't just take a circle and come up with 7 equal pieces. And that was interesting to me. So students might get 100% on a worksheet like this, where we're saying, can you show me that you understand unit fractions? What is the missing number that goes in the bottom? What are the numbers that each object has? Well, all I'm showing you here is I know how to count, and my highest number I have to count to is 8. But that does not mean I understand what a unit fraction is. So if we can park the word fraction, fraction can come up at the end of grade 2, doesn't have to come up anywhere before then. We can just talk about relationships. So if we can do away with the symbolic, don't talk about a numerator, don't talk about a denominator, just talk about a relationship, something that's related to something else, and we'll define how that unfolds with money. Do away with maybe a fraction is. Many times we start with that sentence and then we say it's a part of a whole. It's like a half a cookie, it's half a pizza. So what if we didn't start that way? And this is harder on us than it is on the kids because they've never seen it before, so they're not going to know any different. Talk about fractions, about how numbers are related to one another. We're going to talk about relationships and what those relationships might look like. So fractions can be parts of a whole. Yes, they can. We talked about it. This is an excellent series. the Math Antics do great videos. But now that I've shared with you those 8 pieces, yep, no worries. Those 8 pieces, and we're over here. When you watch that video, you will find that it talks about all the things that we were told we do as North Americans. It speaks to it right off the bat. So good to watch, nothing that's too heavy. That right now. So let's say we take a number line and we're going to just put money on top of that number line. So dimes, I should know. I know that I need 10 dimes to make 100 cents. So just take any number line, and when you've got it labeled on there, just put cents behind it. Make it real. Make it a real world combination. So when I have 100 cents, I have 10 dimes. I can put the dimes on top of each of the places. So what I'm really doing is I'm representing 1 dime at a time out of a possible 10 that are going to take me to 100. Is it a part whole? Yes, but we're not going to define it that way. We're just going to say I have 1 dime that's been related to that loonie, or 10 dimes that I'm going to be building to make my 100 cents. Just unpacking the lingo. That's all you're doing. I've got these pinked out because I would never bring these words up. All I want to do is a relationship. So when I go back to this picture, I want them to lay out their dimes. They can put them on top, whatever they want. And really, when I'm doing anything with money, I'm not going to put a loonie on the bottom and have something at the top that looks different. Keep them the same. So if I want to do half of a loonie, I can do 2 50-cent pieces on the bottom. Okay, if I wanted to do it with quarters, then I could have 1 quarter on top, 4 on the bottom, so that they visually see the dollar amount that makes the 100 cents, but also it helps me to understand what is the quantity that I need on the bottom. So when we do this work, that first important stop from 0 to 10 cents, this is my first out of 10 hops, my first 1/10 hop, my first dime out of a possible 10 that I'm going to have to hop along the way. Is it a part whole? Yes, but we haven't named it that. So this is my 1/10 hop from 0, and each hop I make after that is still 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10. Some students will count those and write them like that. They'll go, this is my first 1/10 hop. Here's my second 1/10 hop. So they'll go second, 2, and put 1/10 behind it. It's like 2 times 1/10, same thing. Some students just write it like this, whatever works for them, okay? And however you want to start showing them that. But what you've done is you've put the hop onto a number line, just like this was 1, 2, 3, 4, 5. I now get that a number has a unit fraction, which has a distance that I can hop and hop and hop and hop and hop. Okay, and Nicole, if you need to go, that's fine. I'll just finish the recording and put it in there. I can do the same for quarters, right? I can put the quarters on here and I can hop. Here's my first 25-cent hop, or my first out of 4 quarters. Here's my second 1 quarter. Here's my third 1 quarter. Here's my fourth 1 quarter, and so on. So we do that with the students for nickels. We do it with the dimes. We did the dimes together as a group. And then we had the students do the nickels, and then we had them do the quarters. They have to skip count by 5s anyway, so there's good practice for them. They have to skip count by 25s. There's good practice for them. Once I've done that, I'm going to fast forward. I could give them a typical sheet that we're used to seeing, and I could just say this is 0 and this is 1. And when this is 0 and this is 1, I can now say, what hop do I need to do? This is my first out of 2 hops. This is my second out of 2 hops. So this gives me my 2/2. This is my first out of 3 hops. So my first out of 3, my second out of 3, my third out of 3. So what you've done after you've done a bunch of money, and there's no rush to get away from that, you can move to something that's a little bit more abstract to see if they can even transfer their understanding, just to a line that all of them start at 0, all of them go to 1, just like they did for $1. So again, some students might write that as 2 1/4 hops, or just 2/4, 3 1/4 hops, or 3/4. Let them choose how they wish to do that. It doesn't matter. So then I can have a conversation about, where do I see the halfway mark in my line? And students might say, well, that's like, this is like our 50 cents out of $1. Yep, you're right. How could I find that? Well, you could take the line and fold it in half. Yep, you could measure it. I guess you could. But in short, what we're trying to do is find a unit fraction that goes in here. So whenever I'm bringing out money, I'm using it to leverage it for a unit fraction. I'm also leveraging it to use it for your number outcomes, for addition, for skip counting. All of those pieces all fit together every time you bring out a question. So in this case, I see five in a row. I subitize quickly. I see a 5 frame or 5 in a row, 5, 10, 15, 20. I could do it by twos, 2, 4, 6, 8, 10, and keep going. I could do the same thing here. So it's talking about the number that I see, the value that I see. I can do that as well. Same thing with my $10 bills, my $20 bills, my $100 bills. I have ways that I can count and skip count. So one of the things that we just finished with a group of teachers in the provinces, we were working on place value. And of the work that Dr. Rogers did, and I've given you a link at the bottom if you want to check out some of her work. One of the 6 aspects of place value, and in her work and her research, she says, these are the 6 pieces. I have to be able to do those 6 pieces well as a student in order to have a good understanding of place value. Not just one, not just 3 of 6, all 6 have to be really firmly embedded. But of all of them, the most important is their ability to rename. And this is important for all of our students as they start. So again, if we talk about mastery to 100, this is where I'm saying, let's make sure that they're really concrete and that they have a good visual understanding of place value, of where it belongs on a number line, where it belongs in the value, the digits within the number itself, and what are the values of those digits. So again, I'm not going to draw my lines down just quickly. I'm just going to go tens and ones. So if I asked how much money do I have here, I would have $36. So I might ask the question, what number is it? 36. I could write it down, 36. What number is in the tens place? When we have those columns, pretty easy. But right now I see the tens, I can see them. And we wrote 36. 3 is in the tens place. How many tens in this number? How many tens in this number is a different question. I see 3 tens. Now, they both turn out to be 3, and for a 2-digit number, those will always be the same. So once we move to a 3-digit number, understanding, mastering those hundreds is really important. How many ones in the number? If they say 6, then we might rephrase it and say, I see 6 loonies in the ones place. But how many loonies would you have to give me for $36? That's how many ones are in the question. So that's the difference of understanding and place value. What number is this? 10, 20, 30, 40, 50, 63. What number is in the tens place? 6, I wrote 63. How many tens in the number? Well, I can see the number of tens. How many ones in the number? So 63 loonies is what I'm looking for. So let's see if we can transfer some of our learning and do some of our skip counting and our values. How many tens are in 50? So if they have to count them out and put 5 down beside it, have them do that. How many are in 100? Same idea. I could ask them if they counted out 10 of them, could you tell me another way to show me that you got 10? We would hope that they would say a double 50 is 150. Counting by 50 gives me to 100. 5 and 5 is 10. How many tens are in 150? So did they understand what was here? So 15. So now let's see if we can transfer the knowledge. How many tens in $120? So again, it's just that understanding, visual of what tens are, because here comes the questions that are going to get to the basic understanding of renaming. I have the number 124, $124. So $124, if I ask, what number is in the tens place? 1, 2, 4, 2. How many tens in the number? And if they really understood what you've asked in the last couple of questions, they won't say 2. Then we go back and say 2 is in the tens position. But how many tens? How many $10 bills could I make in $124? Oh, well, there's 10 over here and 2 over here, so 12, right? That's that getting to the understanding of value. How many ones in the number? I need 124 loonies to make $124. So the bigger the number, the 3-digit number, if you want the columns, put the columns in, just put the dollar values at the top. Just start with that. And then just make it as simple as, what is the number again? 434. How many tens in the question? Or let's go back one. What number is in the tens position? 3. What number's in the ones position? 4. How many 10s in the question? So I need 10 for each one of these, and then plus these 3, so there'll be 43 of them. So I've also given you some links to the Ontario curriculum. They've made a change recently to their curriculum, and a number of their outcomes and work that the ministry has been posting for them, and resources that their teachers groups have been putting together are great. And so again, I'm giving you both links 1 and 2 because some of them are transferable to either one of our grades. So again, these are just some resources as well as some games that you might want to try with just unit fractions. Nothing big, nothing crazy. Okay, so we want to do a continuous review like we've been doing in this example, and I apologize that it went longer, but I really wanted to unpack the unit fractions because that's a big piece that's in where we're starting right now going into December, January. So just always revisit. You've got the money on the number line, skip count it out. Like just keep revisiting all of those different pieces. Leverage money for everything you can. If you see 10 loonies, can I change it? Yeah, I can put them in groups of 2s and make toonies out of them. Or I could make 2 5s out of them, or I could make a 10 of them. It's just that conversation so that when you bring out base 10 blocks, I have a good understanding of what converting is all about. Okay, we can skip that one because we won't have to worry about it. There are 2 sites in here. If you're looking for some number lines and some resources, especially if you're looking for number lines that have unit fractions, those types of things, Sparklebox is a great resource. Everything is created for you and it is royalty free. So you are able to use any of them and download them. And the trajectories that you see here are games that Dr. Newton shared with us that you can go in and have a look and see which ones would I like to do work on in grade 2 right now if I'm making them go to 100, if I'm asking them to do some unit fractions, wherever you're at, those trajectories have some fantastic little games in them. And our sources, and that takes us to our last slide. So thanks so much, you guys. I appreciate that you could stay with me as long as you did. So I just want to wish you all a really Merry Christmas because I won't see you until the new year. And if you're not sure where to find our resources, remember when you click this on our math folder for grade 2, we'll take you to the Moving Forward website. Just make sure that you're logged in again. And then when you come down to the subject area, go to math and find your grade. So here's your grade 2. And you'll see that we've already posted the resources and the slide deck for you. So you have access to it right away. All right, have a great break. I won't see a lot of you before then. So thank you so much for being with me today. And we will see you in the new year.